So picking up right where we left off, this is the you do it part. So you guys try to do this one on your own. Try to modify one or both equations to get a variable to cancel. And of course use parentheses and get something to cancel, get an equation with one variable, solve it, get an answer, plug it back in. And let's see if we could do that. I'll explain it right now in a couple of seconds. So the first thing to do, guys, is to decide what's easier to cancel out, x's or y's. Now, if you say x's, yeah, you could cancel out x's, but in order for this 3x to cancel out with this 5x, they need to be the opposite exact numbers. Or I should say the exact opposite numbers. In other words, this would have to be a positive 15x, and this would have to be a negative 15x. And in order for that to happen, I'd have to modify both equations. I'd have to multiply everything on top by 5 and everything on the bottom by negative 3. That way I could cancel out x's. So if you look at the y's, just take 1 second before you cancel out x's. Look at the y's. Right here I have a 3y, right here I have a negative 9y. I could actually just change this one to become what? Positive 9, and then it'll just cancel with the bottom negative 9. So all I have to really do is multiply the top equation by 3, and then it'll be ready to cancel out with the bottom one. I don't have to do anything to the bottom one, okay? So the top equation is going to become 9x plus 9y equals negative 45. The bottom equation we're going to leave exactly the way it is. 5x minus 9y equals 3. And now we're able to combine, and of course the 9y and the negative 9y cancel out. We get 14x, we get equals, we have a negative 42. And if I divide both sides by 14, I will get x equals, anybody? Negative 3. So there's one answer. How do I find the other? Plug it into any equation you want. Which one do you guys want to do? Top or bottom? Top? Okay, so we're going to take this negative 3 and plug it in right here in the x position. So let me rewrite it. 3 parentheses, we said that was going to be a negative 3 plus 3y equals negative 15. So I'm really going to have negative 9 plus 3y equals negative 15. When I add 9 to both sides, add 9 here, add 9 over here, I'm going to end up with, let me move this up, 3y equals negative 6, which means y equals what? Negative 2. So x is negative 3, y is negative 2. So x is negative 3, y is negative 2. There is your answer. Of course, you could double check it. If I plug in a negative 3 right here and a negative 2 right here, you could just do this, jot down some numbers if you wanted to double check it. So instead of 3 times x, it's going to be 3 times negative 3, that's negative 9. And over here, instead of 3 times y, 3 times negative 2, that's going to be a plus negative 6. Now, if I add negative 9 plus 6, do I get that negative 15? Yes, okay, so I double checked it. The top one, check, it works. Let's check the bottom one. What if I went 5 times x, which is 5 times negative 3? What do I get right here? You get negative 15, okay, and then how about the second one right here, the 9 times y? What do I get? 9 times negative 2, that's going to be negative 18, but with this minus sign, if you think of it as a negative 9 times negative 2, that's positive 18 plus 18. Now if I go negative 15 plus 18, do I get 3? Yes, I do. So I've double checked. Check up here, check down here. I've double checked that negative 3, negative 2 is the correct answer. Now there are special cases. Just like when we graph, sometimes we end up with parallel lines and it's no solution, or sometimes when we graph you end up with the same exact line right on top of each other. That's infinitely many solutions, and if you were to classify it, that would be a consistent dependent. Same situation here, special cases. If you're working on a system with the elimination method and you get something that's always true, like 0 equals 0, Just like before, when something's always true, you get infinitely many solutions. If you end up with something that's impossible, like 5 equals 3, then you say no solution. Just like before, guys, when we did substitution, same thing. If everything cancels out and you end up with something that's always true, it's infinitely many solutions. If everything cancels out and you end up with something that's impossible, you say no solution. So, on this guy, would you like to cancel out x's or y's? It doesn't matter which one you pick. Would you like to cancel out x's or y's? X's, okay. So this is a 6x. What would I like to have down here in order for it to cancel with a 6x? You'd like a negative 6x, right? So you're going to have to multiply that bottom equation, the whole thing, by, by 3. Shouldn't have put a negative. Just by 3, okay? So when you distribute the 3, the top equation is going to stay 6x plus 15y equals negative 12. And the bottom equation becomes negative 6x minus 15y equals 27. Now I'm ready to combine the lines. When I combine the lines, the x's cancel out. That's what I wanted. But then you're like, wait a minute. What's 15y? Take away 15y. It also cancels out, guys. So the equal sign's right here. What's left over on the left side? Nothing. So you have 0. On the right side, negative 12 plus 27, that's 15. Does 0 equal 15? No. So no what? No solution. Right? Or you could put that symbol right there. Boom. So this one's a no solution. If I were to ask you to classify it, you have to understand that that means if there's no solution, that means that they do not cross. They're parallel. That means that they're inconsistent. There is no solution. So you guys could try this one down here. Modify x's or y's, see what happens, and then classify it. Or not classify it, but tell me what the answer is. Go for it. So the thought process, I mean, what do you think would be easier to do? Cancel out x's or cancel out y's? I know it doesn't really matter at the end of it all, but which one would be easier, x's or y's?
Y's.
The y's. How would I change this y to become a positive 3y so it'll cancel with a negative 3y? Multiplying by 3, right? So on the bottom you get negative 12x when you multiply 3 times negative 4x. 3 times y, that's positive 3y. At the very end, 3 times 3 is 9. And the top equation we're going to leave exactly the same. It's a positive 12x, it's a negative 3y, and it's equal to 9. So when we combine the lines, everything cancels, even the 9. So you end up with 0 equals 0. You know that that's always true. So the answer is infinitely many solutions, because it's always true. So we're passing around this worksheet right here, the 6.3 elimination method. Now we are really going to start with baby steps, all right? If you understand the notes that you just took, this is going to be super easy, because we're taking baby steps here. We're going to start solving systems that are already ready to cancel out. You don't even need to do step 1 because it's already set up for you. Okay, so let's all take a look at number 1 here. Now, I want to ask you, what do you want to cancel out, x's or y's? Y's. Now, why would I want to cancel out y's instead of x's? I could cancel out x's if I want, but if I wanted to cancel out x's, I would have to change the whole top equation by multiplying by negative 1 so it could cancel out with the positive 1 down here. But the y's, if you look at it, it's already done. It's already ready for you. So you just draw a line, cancel. X plus x is 2x. Bring down the equal sign. 1 take away 9 is negative 8. And guess what? You have an answer already. The answer is what? Negative 4. What do you do with that answer? You plug it in. So you're going to take the negative 4 and you're going to plug it into any equation you want. I want to plug it into this top one right here. I want to plug in the x. I want to make it a negative 4. So it's going to actually become negative 4 plus y equals negative 9. And then you solve the way you always solve, plus 4. So you get y equals negative 5, and you're done. And if you flip the paper over, you should see that the correct answer is a coordinate negative 4, comma, negative 5. How easy is that? Piece of cake, right? So this whole worksheet, it's already, step 1 is already done for you. So all I want you to do is get used to the process of combining the lines and canceling something out. Now, tomorrow we'll make it a little more challenging where you actually have to modify one or both equations, all right? But like right here, it's ready to rock. What are you going to do? You're just going to combine the lines. These cancel out. You have 2p equals 6. Divide both sides by 2. P equals 3. You have one answer. You want the other answer? Plug it into any equation you want. I want to plug it into the top equation. Instead of P plus Q equals -2, I want to go, I want to go 3 plus Q equals -2. All I did was rewrite that top equation, but substituting the 3 in. And then I'm going to subtract 3 on both sides, and I want to get Q equals -5. So the answer, it's not an XY coordinate, but we could still put it in alphabetical order as a coordinate. It's 3, -5. Simple as that, right? Some of them do need a little bit of modification. Now, what do I mean by that? A little bit of modification. Let's look at number 8. Would you want to cancel out X's or Y's? X's are easier, obviously. And what kind of modification do you need to do? All you have to do is multiply the whole thing by what? -1, right? So, I mean, this is like the hardest it gets right here. Modifying one of them by multiplying by -1. But for the most part, this worksheet is cake. It's just to get you more comfortable with it. Tomorrow we're going to do the more challenging ones. So on the top one, you end up with just rewriting the top one. The bottom one is going to change to a -3x, to a +15y, and to a +6. Just changing all the signs, multiplying everything by -1. And now you're ready to combine the lines. It's called linear combinations because we are combining the lines. And then it's also called the elimination method because the whole point of combining the lines is to eliminate a variable. And we have a new simple one variable equation left. That will be 6y equals -6, which means that if you divide both sides by 6, y equals -1. There's one answer. All you got to do is plug it in to find the other answer. I want to go with the top equation, -1. I'm going to plug it in right here into the y. So it's going to be 3x minus 9y, but instead of y, I'm putting a -1 equals -12. Okay, so I really have a 3x plus 9 equals -12. And let's solve this thing. I want to subtract 9 on both sides, and I'll get 3x, I'm running out of space here, equals -21. Because if I subtract 9 from -12, it becomes -21. My final step would be to divide both sides by 3, and I will get my second answer, which is actually my first answer. X equals what? -7. So as a coordinate, that'll be the coordinate -7, -1. Those are your X and Y values. If you check the back of your worksheet, you'll find out that that's correct, I hope. Now, of course, on a test, you'd have to actually plug in your values and double check by plugging them in and making sure that it works on both top and bottom.